Hello. So let's solve this application problem. This application problem is talking about an exponential growth rate. It says in a specific city in the year of 2012, they had around 7.05 million people. And they said this rate is at a 2.77% per year. Part A says, write the exponential growth function. And as you notice here, we already have the function lettered as P of t, meaning P is the name of the function, and T is going to represent the number of years since 2007. Therefore, P of T will give us the population in millions. It's going to give us our outcome. So I got P of T is equal to P initial, so population initial. So that's what we're going to let P represent. And times E raised to our K, our constant, times T time. So again, P of T, where that is our function notation, P is representing the function as population, and T is the number of years since 2007. K is my constant. So now we got our formula or our function notation. Now let's plug in what we know. Well, we know that the initial population for 2007 is 7.05 million. And it's times E raised to my percent. Well, we need to write that in decimal form. Guys, if you don't remember how to do that, you can divide it by 100%, or you can move the decimal 2 places to the left. And so this is going to be my K times T. So here it is. This is my, whoops, didn't give myself enough room. I write too big, don't I? It's going to be P of T is equal to, and here is my function, which is also, some people will call it equation. Also going to be called a model. All right. So now that we have that, we can go to part B. Part B says the population of the city in 2019. So we're going to estimate what was the growth since 2007. So what we need to do is take that 2019, subtract 2007, so we know how many years. And that's a total of 12 years that's passed. So now that we got that, we're going to plug it in our model, our function notation, our equation. Okay. And again, remember, T is years, is the time. So I'm going to put approximately instead of equal to. When we type it in our calculator, I get an output of 9.8. I rounded to the nearest tenths. Be sure and read the directions. It may ask you to round more or less. All right. So it's saying the population, if our growth rate does not change, right, that percent rate here does not change, in 12 years, the population should be around 9.8. Well, part C says, well, how many years will it take to grow to 14 million? All right, so let's solve for that. We're going to take our function. And if you want to rewrite the original, go ahead. So that way you can see where you're plugging everything in. So I got my P of T. It's going to be 14 million, right? Because that's the outcome we want in the end. And then I have my initial, which is the 7.05. That's what we started with. E raised to my K in this case is the rate that the exponential growth is changing. And I'm going to raise it to T, because we're trying to see how many years it's going to take for our outcome to be 14 million. Now I need to divide both sides by the coefficient on E, because E is raised to the T, and T is what we're solving for. So we have to get T by itself. So there's a series of steps we got to go through. So once I did this, I'm gonna rewrite this for a second. Now I got 14 divided by 7.05 is equal to e raised to this. Well, there's a rule in our natural log and logarithm rule that whenever we're trying to get the power out, we apply a specific rule. And since we're working with e, right? We're working with this e here, we can use the natural log. And why do I want to use natural log? Let's talk about it. Natural log of e is equal to 1. So it's perfect, right? So what I'm going to have to do is take natural log of both sides because what you do to one side, you have to do the other. Now, I just told you the natural log of e is 1, but in order to apply the natural log of e, that means I can apply the power rule, meaning the power comes to the front when you apply the natural log or the logarithm. So I'm going to rewrite this. So this is what I got. I'm bringing this to the front, and when I bring this to the front and undo it, I'm gonna do an extra step, but y'all don't have to. This here goes to 1, and then 1 times that, well, then that just gives me what I'm multiplying it to. So next, I want to divide by this coefficient here because I want t to have a positive 1 coefficient because I'm trying to tell you what t is. Oops, that should be a decimal. My handwriting got a little sloppy. So I'm going to rewrite it where t's first. I'm going to write the exact because this is exact. And let me write just a little neater so you can read what I'm writing. And I'm determined to put a 0 first. Let's almost there, guys. Now, and then I'll type it in my calculator. I'm going to round to the nearest tenths. That'd be a lot easier. And my outcome came to 24.8. So it's going to be approximately 25 years after 2007 before it gets up to 14. Now that's approximately because, you know, we're basing this on statistics and on the fact that it's not going to change, right? Thank you.